Hello. Today we will go over some factoring problems. So I would like to start off by first talking about this standard form of a quadratic equation, which is just with this problem here is just in this form. And the A, B, and C are all coefficients. But I wanted to talk about that because to factor these, I just like to think of it as, like, for our C, we need to find two numbers that multiply to get C, and then we're going to have those exact same two numbers must also add to get B. So for this problem here, I like to write my parentheses first because then I just need to fill in whichever numbers go there. So 6 is our C. So we're going to have two numbers that multiply to get 6. So, and then they also have to add to get 5. And just by looking at this one, you can tell that 2 and 3 will multiply to give us 6, and 2 plus 3 will add to give us 5. But the 5 is negative, so we have to account for that. So you're just going to make both of these negative because that will still give you positive 6, but if you add them, it will give you a negative 5. So that's how we get that to work out. So our two numbers in here are going to be -2 and -3. And if you're not sure of your answer, you can check it by foiling everything back. So if we just distribute like this, we get x squared. X times -3 is -3x. -2x, and then -2 times -3 is +6. So then we'll get this. So that's how you know it's correct, because it distributed to the original problem. So if we look at this next example, these numbers are a little bit bigger, but I'm going to start with writing my parentheses. And if you need to, just think of all of the factors that 72 has. And once you practice these, it'll come to you a little bit quicker. But I immediately think of 9 and 8 for 72 because I know that also adds to get 17. So we have 9 times 8 is 72, and 9 plus 8 is 17. But this one is exactly the same as the last one, and the 17 is negative, so we need to make this -9 times -8, 72. And you don't need to write all this out, I'm just writing it out to show that this equals that. So these are our two numbers for this one. Now, we'll do a couple more examples. So we need two numbers that multiply to get -42, and those same two numbers must add to get 1. There's an understood 1 there. So I immediately think of 6 and 7 because that gives me 42. This one is a little different than the last one. So we need a -42, so we can get that by putting a negative on either the 6 or the 7, but only one of them can be negative to give us a negative answer. And since our middle term that we need the sum of these two, this one's positive. So we know the bigger number needs to be positive for us to get a positive sum here. So we're going to have -6 times 7 is -42. And -6 plus 7 gives us +1. So that's how we figured out our numbers for this one. We're going to have a -6 and a +7. And just to check it again, to make sure your work is right, just distribute it back. And we'll get this. And that's the same as the original problem. So we know we did that one right. And next I have another example that's a little bit different, but it is still a different kind of quadratic expression. This is called a difference of squares. And this one is, you can think of it as it's in this form here, because the 4 is a square, right? You can write it like this. But to know what this one factors to, whenever you have a problem like this, just know that the middle x term always simplifies out. So this one will factor out to this. So if you FOIL this, you'll get x times x, which is x squared, x times 2, which is 2x, negative 2 times x is negative 2x, negative 2 times 2 is negative 4. And as you can see, these will add to 0, so then you are left with this. So if you have a difference of squares, they're always going to have the same numbers in here, but the signs are going to be opposite, and that will always give you that answer here. So we could try another one. It works for everything else too. If we had this one, 9 is a square, we can write it like this. So that one is going to factor to this. And you can check it. It'll be the same for all of them because that middle term is going to simplify. So you'll have x squared plus 3x minus 3x minus 9. And these two simplify, so you get this.